Lecture 2. Measurements and Calculations. Objectives. Show how very large or very small numbers can be expressed as the product of a number between 1 and 10 and a power of 10. Learn the English metric and the international system of measurement. Use the metric system for measuring length, volume, and mass. Understand how uncertainty in a measurement arises. Learn to indicate a measurement uncertainty by using significant figures. Learn to determine the number of significant figures in a calculated result. Learn how dimensional analysis can be used to solve various types of problems. Learn the 3 temperature scales. Learn to convert from one scale to another. Define density and exit units. Why measurements matter. Chemistry is an experimental science. To describe matter accurately, scientists rely on measurements, units, and calculations that follow clear rules. Understanding these tools allows us to communicate results reliably and solve real problems. 1. Scientific notation. Concept. Very large or very small numbers are written as
number equal to A times 10 to the n, where A is between 1 and 10. Examples. This big number that you can see here, what you do, you have the point at this in this place, then you move 1, 2, 3, 4, 5, 6 times to the left. Then you write 5.6 times 10, and as you move 6 spaces to the left, the exponent is positive 6. In this number is a small number, then you move the dot to the right. In the other one was to the left, but here is to the right. So 1, 2, 3, 4, and then you write 4.2 times 2, 10, 2, and as you move to the right, the exponent is negative, and 4 indicates the times you move the dot to the right. This is a way you are going to express scientific notation. Big numbers and small numbers.
Why do we use it? Makes numbers easier to read. Simplifies calculations. Reduces errors. Exercise. Convert to scientific notation. 72,000. 0.0068. 2. Measurement systems. Metric system and SI system. Chemistry uses the metric system, which is part of the International System of Units, SI.
Here you can see the quantities: length, mass, volume, temperature. In the international system, the unit for length is meter, and the symbol is M with lowercase. For mass, the kilogram, and is kg with lowercase. Volume, liter with capital L, and temperature is Kelvin, K, capital. The common prefixes are kilo, 10 to the third, centi, 10 to negative 2, milli, 10 to negative 3. Here you have an exercise. Which is larger? 1 kilometer or 1 meter? 500 milliliter or 0.5 liter. In order to do this exercise, all what you have to do is to convert both units into one. Well, in this case, I'm going to keep 1 kilometer, and I'm going to change 1 meter into kilometer. From meter to kilometer, we have 3 spaces. Then I have to multiply by 10 to the third. So 1 meter is equal to, in this case, you have to divide, then it will be 0.001 kilometer. Then when you compare 1 kilometer and 1 meter, of course, 1 kilometer is larger. Do the same thing with this, change milliliter into liter, and as you can see, here is liter, centiliter, deciliter, centiliter, and milliliter. Then, if you are here in milliliter, you have to divide by 10, 100, 1,000. Then 500 milliliters divided by 1,000 is equal to 0.5 liter. In this case, you can see that 500 milliliter is equal to 0.5 milliliter. Then they are equal. Let's go again. We are in milliliter. We have to divide by 1, 10, 100, 1,000. 500 milliliter divided by 1,000 is 0.5 liter. So they are equal. Let's continue with our lecture.
Three, measuring length, volume, and mass. Length. Ruler, meter stick. Unit, meter, m. To measure the length of the side of a geometrical figure using a ruler, follow these steps. Step-by-step guide. 1. Place the figure on a flat surface. Ensure the paper or object is stable so the ruler doesn't slip. 2. Align the ruler correctly. Position the ruler so that one end of the side you want to measure starts precisely at the 0 mark, not just the edge of the ruler, since some rulers have a margin before 0. 3. Read the measurement. Look straight down at the ruler to avoid parallax error, misreading due to angle. Note the number at the point where the side ends. This is the length. 4. Record the units. Rulers may show centimeters, cm, millimeters, mm, or inches. Always write the unit with the measurement. Example, if the side ends at 5.2 centimeters, record it as 5.2 centimeters, not just 5.2. 5. Double-check accuracy. If the side is diagonal or not perfectly horizontal/vertical, make sure the ruler is aligned along the side itself, not tilted. For irregular shapes, measure each straight segment separately. Example. Suppose you have a square drawn on paper. Place the ruler along one side, align the 0 mark at one corner, and read the value at the opposite corner. If it reads 4 centimeters, then each side of the square is 4 centimeters long. Common mistakes to avoid. Starting from the edge of the ruler instead of the 0 mark. Reading at an angle causes parallax error. Forgetting to note the unit of measurement. Volume. Graduated cylinder. Read at the meniscus. Unit, liter, L, or milliliter, ml.
Okay, it's very important the position that you use to read the liquid. This is incorrect. This is incorrect. This is correct. This is the correct position. And the meniscus sometimes is this way. In this case, you have to read the lower part of the meniscus. Then the reading is this, another one that you make in this place. Sometimes the meniscus is the opposite, is this way. So you have to read at this place and not at this place. This is incorrect. This is correct. In the case of the form of the meniscus. Generally, this is what we are going to find. So let's begin with our lecture.
Mass. Balance. Unit gram, g, or kilogram, kg. Exercise. Which instrument gives the most accurate measurement of 25 milliliters of liquid? A beaker B. Erlenmeyer flask C. Graduated cylinder D. Test tube.
The correct answer is C, is the graduated cylinder. A beaker is not an instrument of measurement. An Erlenmeyer is not. And a test tube is not an instrument. The only instrument that we have here is the graduated cylinder. That's why this is the answer. Which instrument should be used to measure the mass of a coin? A thermometer? Well, I'm talking about the mass. Then a thermometer is for temperature. A spring scale, look at this. This is a spring scale. This is the correct answer because this is the instrument to measure mass. Let's go. Well, sorry, I made a mistake. The spring scale cannot measure a penny. How are you going to supposed to put the penny here? Then the correct answer is a balance. Because in a balance, I'm going to show you a balance. A balance is an instrument where you can place the nickel or the penny, and then you can measure the weight of the penny. This is the instrument that you're supposed to use. You can say a scale, or you can say a balance. That's the correct answer for this question. Well, in the following one, measuring the uncertainty. Let's go here and let's see.
4. Measurement uncertainty. Concept. No measurement is exact. Uncertainty comes from instrument limitations, human estimation. Rule. Always record all certain digits plus one estimated digit. Example. If a ruler reads between 2.3 and 2.4 centimeters, record 2.35 centimeters. The reading is between 3.6 and 3.7, so you must report 3.65, and the last digit is estimated. Exercise. Why is uncertainty unavoidable in measurements? Uncertainty is unavoidable in measurements because every measuring instrument has limited precision, and every measurement requires human estimation. No tool can give an infinitely exact value, and slight variations in instruments, reading scales, environmental conditions, and the observer's judgment all introduce slight differences. As a result, every measured value is an approximation of the actual value, and uncertainty is an inherent part of all scientific measurements.
Let me stop into here and let me tell you something. For example, this is very clear. If the measurement is between 3.6 and 3.7, you're going to report, you're going to estimate the last digit. The last digit in this case is 5. But suppose that it is sharp at 3.6. Then you are going to say 3.6, that's the number you have to report? No. You also have to estimate the last digit, and it is exact at 3.6. You are going to write here as 0. Then the answer is 3.60 centimeters. Same way, if it is sharp at 7, you are going to write 3.70 centimeter, and this will be your answer. Always, you have to estimate the last digit. Don't forget that. If not, the number of significant figures is incorrect. And it has to be with the uncertainty of the instrument that you are using. Okay, let's continue then. Now I think that you understand. If not, you can ask me and I will answer these questions and I will explain you another way until you understand.
Why is uncertainty unavoidable in measurements? Uncertainty is unavoidable in measurements because every measuring instrument has limited precision, and every measurement requires human estimation. No tool can give an infinitely exact value, and slight variations in instruments, reading scales, environmental conditions, and the observer's judgment all introduce slight differences. As a result, every measured value is an approximation of the actual value, and uncertainty is an inherent part of all scientific measurements. 5. Significant figures. Definition. Significant figures, sig figs, show the precision of a measurement. Basic rules. Non-zero digits are significant. Zeros between non-zero digits are significant.
Okay, let me stop into here. For example, if you have a number that all the digits are different from 0, you consider that this number has 3 significant figures. If you have zeros between non-zero digits, for example, 1, 0, 3, this 0 that is between two non-zeros is considered significant. So this number has 3 significant figures. Oh, leading zeros are not significant. For example, this number that you observe here, these 3 zeros are leading zeros, so they are not significant. Here you have only one significant figure, that is the number 1. Got it? Okay, let's continue then. And trailing zeros are significant only if a decimal is present. Let me tell you something here. For example, when you have 0.0001, these zeros to the left are not significant. This number has only one significant figure. But, for example, in this number that I gave you up, 1,000, I told you that 1,000 has only one significant figure. But what happened if I put a zero, a dot here? If you have a dot, then these zeros are consider significant, and this number has 4 significant figures. Then the dot is very important when you are considering the number of significant figures. For example, here we have more examples. This number has 1, 2, 3 significant figures because these zeros are not significant. These zeros are not significant, so it has only 2, but this one, because of this dot, has 4 significant figures. Let's go. Then now we are going to continue with our lecture.
How many significant figures? 0.0302, 5.00. 6 significant figures in calculations. Rules. Multiplication/division considers the fewest sig figs. Addition/subtraction considers fewest decimal places. Example.
2.5 veces 3 y 42 igual a 8 y 55.
Sorry. 2.5 times 3.42 is equal to 8.55. Okay, what's the problem here? What's the problem here? As you are multiplying, you take into account the number with least significant figures. In this case, this number has 2 significant figures, while this has 3. Then your answer must have only 2 significant figures. That's why, even though this number, the answer is 8.55, your answer must be 8.6 with 2 significant figures too. Understand? This is apply also for division. Well, here you have an exercise. You can calculate this and you can give me the answer. Well, in addition, for example, when you have 3.01, 2.1, then you are adding in this case, or you are subtracting the same thing. What I recommend you in order to apply it correctly is to make a line by here. Then you do your exercise. You can use a calculator, of course, but you know that you have to report only this part. And as the first number that you have to skip is lower than 5, you skip this number. And the answer is 5.1. If the number here were 5 or higher than 5, then you round up and your answer could be 5.2. Okay? Then remember, for multiplication and division, you consider the fewest significant figures. And in addition and subtraction, you consider the fewest decimal places, or the number with least significant figures. Let's go now to the method of dimensional analysis. I always say that dimensional analysis is the math in chemistry. This method is very, very important. Let's continue as we are doing, and
Dimensional analysis is a method that uses units to guide calculations and prevent errors. For example, to convert 500 centimeters to meters, we multiply by a conversion factor that cancels the unwanted unit.
Okay, for example, here you have a problem. In this case, you know that 1 meter is equal to 100 centimeter. I use this conversion because the problem is to go from centimeter to meter. The given number is in centimeter. So the best conversion factor that you can make from this is this way. In such a way that you can cancel centimeter with centimeter and your answer is in the unit that you need to report. Okay? Let's continue then. Let's continue with the following example. For example, you need to go from centimeter to a meter, and in the same way, you do this operation and you have the answer. The key idea is use equivalences between two known units to build conversion factors. Then you need to make the conversion factor and apply this in such a way that you can cancel the given answer, and the unit that you will get is the one that you are asked for. Here you have an exercise that you can do, and giving you here the conversions in such a way that you make the conversion factor the given unit and the unit that I want you to convert the given number. All right, let's continue then with a temperature. And let me go here, temperature scales.
8 temperature scales. The 3 scales. Celsius, degree C, lab measurements. Kelvin, K, scientific calculations. Fahrenheit, degree F, everyday use, US. Conversion formulas.
Mayúscula K igual a grados mayúscula C más
Okay, the Kelvin is equal to centigrade, Celsius degrees plus 273. This is the formula to convert Celsius into Kelvin. In order to convert Fahrenheit into Celsius, you have to use this formula. Here you have an example of how to calculate or to convert 25 Celsius into Kelvin. You can stop the video and you can see the operation. Here you have 2 more exercises you can do. And let's go to density. Density, by definition, is the mass per unit of volume. And the units are grams per milliliter or grams per cube centimeter. Example, a metal has a mass of 54 grams and a volume of 6.0 milliliter. So density is the mass divided by the volume, and the given or the answer for this is this number that you see here, 9.0. Look, you're doing a division, so you have here a number with 2 significant figures, and here a number with also 2 significant figures. Then your answer is supposed to have also 2 significant figures. Understand? Okay, let's continue then with our lecture.
Steps to measure the density of a liquid. Measure the mass of the empty container. Place a clean, dry graduated cylinder or beaker on the balance and record its mass. Add a known volume of the liquid. Pour the liquid into the container and read the volume at the bottom of the meniscus at eye level. Measure the mass of the container with the liquid. Record the new mass. Calculate the mass of the liquid. Subtract the mass of the empty container from the mass of the container with the liquid. Calculate the density. Use the formula.
Well, the formula, as you can see, is density is equal mass divided by the volume. And then,
Report the result with proper units and significant figures. Standard units are G/ml or G/cm superscript 3.
okay, grams per milliliter or grams per cube centimeter. Let's see which one are the steps to calculate the density of a solid. Then here in the liquid, as I told you before, what you're supposed to do? Well, you have the liquid, you introduce, you measure the weight of an empty graduated cylinder. Then you have the mass of the graduated cylinder that is empty. And then you introduce a volume of water, for example, 10 milliliters, and then you get the mass of the graduated cylinder plus the water. If you subtract this mass minus this, will give you the mass of the water. And then you introduce the mass of the water here and the volume that you used here, and then you can calculate the density of the liquid. But what will happen if we are in front of a solid? Well, it is pretty easy to determine the mass of the solid. You use a balance or a scale as you wish, and then you record the volume in grams. And then the problem is how we can measure the volume. If it is a regular shaped solid, like a cube, a cylinder, etc., you can measure the dimensions, length, width, height, radius, with a ruler or a caliper, and then you use the formula for the volume and you can calculate the volume. But if it is an irregular shaped solid, the best method is using the water displacement. I will show you now what is this method.
Use water displacement.
For that, you are supposed to
Record the initial volume of water in a graduated cylinder. Submerge the solid completely. Record the final volume. Volume of solid equals final volume minus initial volume. 3. Calculate the density.
Well, to calculate the density, we use the same formula as we have done before. And then you had to report your answer in grams per milliliter or gram per cube centimeter. Let me tell you something that is very, very important. Remember that 1 milliliter is a capacity unit. Milliliter is a capacity unit, is equivalent to 1 cube centimeter. Then in chemistry, we use one or the other because they are equivalent. In 1 centimeter, a cube centimeter, you can have 1 milliliter of a liquid. That's why you can use these 2 units. And don't forget to use the correct significant figures in your answer. Here you have an example of how to calculate the, the volume and then the density of an irregular solid. This, you can stop the video and you can see how I solved this problem. Okay? Here you have another example. Stop the video and look at the operations. And here we have another exercise that you're supposed to do by yourself. So, conclusions. Let's go to conclusions.
Conclusions. Measurements are not just numbers, they are numbers with meaning, units, uncertainty, and rules. Mastering these tools is essential for success in chemistry and, more generally, in science. Question 1. Measurement and precision. True or false, a digital balance that reads to 0.01 G eliminates uncertainty in mass measurements. Correct answer. False. Why it's incorrect. All instruments have limited precision. The last digit is always an estimate, so uncertainty never disappears. Question 2. Scientific notation. True or false, the number 0.00420 has 2 significant figures because the zeros are not important. Correct answer. False. Why it's incorrect. The trailing 0 after the decimal is significant. The number has 3 significant figures. Question 3. Instruments. True or false, a beaker and a graduated cylinder will give the same accuracy when measuring 25.0 milliliters of liquid. Correct answer. False. Why it's incorrect. Beakers are for holding/mixing, not precise measurement. Graduated cylinders are more accurate. Question 4. Density. True or false, if 2 objects have the same mass, they must have the same density. Correct answer. False. Why it's incorrect. Density depends on both mass and volume. Different volumes give different densities. Question 5. Dimensional analysis. True or false, in dimensional analysis, numbers matter more than units. Correct answer. False. Why it's incorrect. Units guide the calculation. If units don't cancel correctly, the setup is wrong. Question 6. Temperature. True or false, an increase of 10 degrees Celsius is the same size change as an increase of 10 K. Correct answer. True. Why it's correct. Celsius and Kelvin scales have the same size degree, they differ only in 0 point. Question 7. Significant figures in calculations. True or false, the result of 2.50 by 3.4 should be reported with 3 significant figures. Correct answer. False. Why it's incorrect. The result must have the fewest sig figs 2 significant figures. Question 8. Density of solids. True or false, water displacement is used to measure the mass of an irregular solid. Correct answer. False. Why it's incorrect. Water displacement measures volume, not mass.
Well, as you can see in all the lectures that we are having, I am asking you the type of question that you will have in the exams and in the quizzes. I'm not going to do questions where you are supposed to copy and paste from artificial intelligence. You are supposed to express your ideas with your own words. You're not supposed to copy and paste. Remember that I can see when you copy and paste from artificial intelligence, and in this case, believe me, I'm going to give you a 0 because we need more to think than to memorize or to have a grade that is not my own, that belongs to an artificial intelligence. Even though artificial intelligence is a very, very useful tool in our hands, you are learning You are learning, and you're not going to be artificial intelligences. You are supposed to be students that think by yourself. Well, that's all for this lecture. Thank you.